Hi everyone, Charles from The Food People here. I hope you're all keeping safe and well. It's my great pleasure to welcome CEO and founder of Remy Robotics, Yegor Traiman. Yegor joins me to talk about robotics in food service, the difference between industrial and adaptive robotics, culinary engineering, and of course the Remy kitchen and how it differs from the conventional food service environment, and of course much more. Welcome, Yegor. Great to have you here.
Thank you very much. Very glad to be here.
At The Food People, we're very clear about why we do what we do. We're champions of change, driven every day by our intent to shift the future of food and drink by harnessing the power of trends. And this In Conversation With series is all about talking to people and brands and businesses across the spectrum of food and drink to find out more about why they do what they do, how in their way they're championing change and shifting the future of food and drink. And I think that's a great segue almost into our conversation, because what you do is very much shifting the future of food and drink. So Yegor, can we start with your background and how and why you got into robotics?
Yes, sure. So all my life is dedicated to high tech. I have a degree in cybernetics. I started my career as a software engineer. But quite quickly, I switched to more entrepreneurial or business development direction. First, in international IT consulting, which actually taught me how to easily jump to any new space or business environment.
Yeah.
Then innovative IT and telecom startup, which we turned into a unicorn and sold.
Yeah.
And then with the same team, we started Arrival, British electric vehicles manufacturer or tech company, as we like to say. And at some point, and now it's publicly listed company at Nasdaq Stock Exchange. And at some point, it wasn't the vision from the very beginning, but at some point, the main reason to be for Arrival, or the main thing of Arrival, became flexible adaptive robotics and the way how the vehicles are produced, not using a traditional industrial manufacturing methods.
Yeah.
A conveyor with industrial robots alongside, but new type of robotics. And this is how I got into it. And then at some point of time, I just realized that cars are not my true passion, but food has always been. And food is, from my point of view, is the only 24 hours, 7 days a week, 365 days product, which has a connection to every one on daily, if not to say on hourly basis. And with the recent developments and artificial intelligence, and again this flexible adaptive robotics algorithm, I realized that it can create so much positive and exponential impact to the industries beyond industrial spaces, which I decided to apply it to food.
Yeah.
And I agreed with my partners. I left Arrival at some point, moved from the UK to Barcelona, and started over from scratch here.
And can you tell us a bit more about what kind of led you to food service applications? What is it I guess what's the problem that you're trying to solve in food service? Is it wastage? Is it labor? Why do you feel that robotics are so relevant for the food service application?
If you asked me several years ago, or probably anyone in this space, you would get an answer, multiple answers. More efficient business model, more sustainable, less wastage. But now in this post-pandemic era, there is, I would say, just the main problem is labor shortage. And all the rest adjust the consequences, because restaurants just can't operate. There is no people.
Yeah.
For example, for one restaurant, you might be super successful, super efficient from your operations. You don't have food waste. But if you want to expand, if you want to scale, you can't.
Yeah.
For other restaurants, they are struggling because of quality and consistency, again, because of the labor issue. So I would say labor shortage is the main problem. And of course, in this case, robotics is very self-evident solution for such type of a problem.
Yeah. And is it labor? Is it labor or skills, or is it the fact that it's also, food service is inherently unsociable as well? Is it those kind of issues within labor as well?
Yes, of course. But again, because of the problem, there is just not enough people. People don't want to work in this very physically demanding and low paid space.
Yeah. Okay. We're all familiar with, I think, with seeing robotics. You mentioned automotive applications. When you think of robotics, you think of something that's very linear, and conveyor belts, and that's certainly what I think about when I think of industrial applications. But you're talking about flexible and adaptive robotics. Can you just explain the difference, the fundamental difference between the two?
You're right. The most application of robotics right now are in the industrial space. And what's the main characteristic, I would say, of these applications? So usually it's custom built solution around a single specific product type.
Yeah. Okay.
A car model. You build or you create a design of this product, then you seal it, you freeze it, nothing can be changed afterwards. Then you call for system integrators who come and build, again, a specific custom robotic solution around this specific product or this specific design. And then for the next years, you keep doing absolutely the same. In most of the cases, very repetitive tasks which are very physically demanding, and nothing can be changed. And if it's absolutely reasonable for industrial spaces, because you can sell millions of cars without any changes. The food service industry requires completely different level of versatility. And such type of approach probably might work, I would say, just with the only product type, pizza, because it's the biggest food category. But with the rest, which requires lots of changes, and you are not able to build the entire model of your restaurant just on one product type. You have to add, adjust, expand your menu. These methods won't work. And those companies who started to apply the same industrial robotics method to the food service space, in most of the cases, they're ending up with vending machines.
Yeah.
Which are the same conveyors.
Yeah. Yeah.
And of course they're unflexible. They have limited throughput and capacity, and the main problem, they're not scalable because they cost like an airplane.
Yeah. Yeah. So what is then, I guess, flexible adaptive robotics? If that's the linear industrial world, how do you define flexible and adaptive robotics?
For us, instead of being technology limitations driven, we asked ourselves what the industry requires.
Yeah.
And I would say there are four main pillars. One, to cook multiple food types, to be flexible and adaptive from throughput, layout, capacity point of view.
Yeah.
And to have at least a capex parity with the existing kitchen equipment, because no one in this space can make decisions based on long-term cost of ownership model. People need to take the decision here and now. And if you approach the problem in such type of a way, you would definitely understand that again, single process automation of vending machine won't solve the problem. At the same time, we have to be reasonable here. Robots are still very, very far away from the flexibility and dexterity of which we humans have. And to again approach it in very straightforward way, let's try to automate the existing processes, the existing recipes. Won't work, unfortunately, because right now in the world where everything was designed and built by humans for humans, there is just a little space for the robots, and not in the food, and again in very versatile and flexibility demanding food service space. And that's why we say, or kind of our method is based on the combination of culinary engineering and flexible adaptive robotics. And probably it's very difficult to explain one without another. So if you allow me, or if you have further questions related to what culinary engineering is,
let's talk about that now. That's what is then. You referenced a couple of times now culinary engineering. What does that actually mean, and how does it work with flexible adaptive robotics?
Yeah. So, and coming back to your question about the difference with industrial robotics methods. I would like to give you this analogy. Again, if you start to automate cooking processes in a standard way, let's teach a robot how to steer, how to flip, you end up with nothing. You might teach a robot how to, I don't know, cut a cucumber, but if tomorrow you need to cut a tomato, it will take you another year of R&D.
Yeah.
And in our case, instead of every time building a specific robotic solution around a single product type, we've once built a specific cooking framework around the robots.
Yeah.
But now this cooking framework allows us to cook almost anything, plus be flexible, adaptive, and have cost parity. And again, it's impossible just trying to automate the existing processes. And in reality, food has always been a product of technology. You can take, there are lots of examples. Canned food.
Yeah.
What is absolutely normal for us right now, 2 centuries ago was a huge innovation made by Napoleon army to invade Russia. White rice, frozen food, refrigerated food, all of these were products of technology. But again, right now we don't think about this in this way. For us, it's just tools, methods. And again, my main statement here that you shouldn't expect that in the nearest future, the food which is cooked by the robots will be cooked in the same way we used to cook. It should be something new. So, and again, if there is a single main advantage of the robots where they outperform humans right now is precision.
Yeah. Okay.
And we built this new cooking method or cooking framework, trying to maximize robots' advantages while trying to avoid their weaknesses or disadvantages. And to do this, we had to kind of invent, if you want, a new discipline, which is a combination of food R&D, food science, culinary creativity. And right now, again, it allows us, using this cooking framework, cook almost anything.
And that's what you call culinary engineering, is that right?
Yeah, exactly.
Yeah, okay. Can you give us an example of what the process looks like in one of your kitchens, and how does that differ from a conventional kitchen?
On the one hand, there are three key elements, I would say. Adaptive robots, which orchestrate everything. And adaptive means that they move not based on a predefined trajectories like they do in industrial application spaces, just moving apart from point A to point B, but they adjust their behavior, their actions based on robots' perception, computer vision, and some other artificial intelligence algorithms, which again allows them to adapt to different layouts, spaces, shapes, and be really flexible. The second key element of our cooking framework, robotic oven, because again, as I said, the main advantage is precision.
Yeah.
And if you take a traditional cook, a famous cook, it can cook consistently amazing dishes based on his long life experience, senses. He sees, he hears the flips, he smells, but it's very difficult to replicate it, and to teach some other. And robots don't have that.
No.
They don't have experience, they don't have sensitivity. But they can operate, again, with precision based on algorithms and formula, based on precise inputs. They can give very precise outputs. And of course, it's not about, as I mentioned before, steering, flipping, chopping. No. The robots are still not very reliable in these operations. But at the same time, I would say the food service industry is very well equipped with smart equipment, rational ovens, Mary chefs, Thermomix for home appliance. But unfortunately, we humans, in reality, use up to 10% of the functionality of this equipment, because for us it's super complicated to understand the recipe, how to program, and in most of the cases, restaurants buy such type of equipment, which cost 15 rand, and they use just to warm up something. But for robots, it's super easy. This is the way how the robots can cook. So, and coming back to our framework, so we built our own robotic oven. It's a combination of heat, impingement, RF technology, but again, the most important thing, it's super precise. By doing multi-physics simulation, we know and we understand, and we can control the temperature and heat distribution at every single moment of time.
Yeah, okay.
And the third element, that's also very, very important. It's a special capsule which we invented. Because again, if you want the robots to deal with multiple shapes and textures, this is what they can't do. That's why we use a special capsule. You can think of like an Nespresso capsule, for example, where we put the ingredients, and then the robots putting these capsules into these robotic ovens.
Yeah.
They cook it with the maximum level of precision using aesthetic parameters, weight, granularity, viscosity, and dynamic parameters, state of meat, medium rare, or in case of delivery, even how far the customer is
away from the preparation center.
From the because if at 20 minutes away, the dish most likely will be fully cooked. But if it's 30 minutes away, it will be a little bit undercooked to let it be finally cooked while on the go. And so 3 elements which we use inside our robotic kitchen, but it means that of course we are not able to do it without humans' help.
That was my next question. Yeah,
exactly. But in our case, it's not a collaboration because the kitchens are fully autonomous. There are no humans. All cooking is done absolutely autonomously. But I call it a partnership.
Yeah.
Because we utilize the existing value chain of food service industry, which is hub and spoke.
Yeah.
You have a prep kitchen, and then you have multiple outlets and multiple locations. And in reality, like labor shortage or main problems, inconsistency, wastage happens in the outlets, not. And from this point of view, so people or cooks at prep kitchen, they clean, they peel, they put ingredients into our special capsule, and then these capsules shipped to robotic kitchens, and then the magic starts.
So the human does the creative piece, I guess, coming up with the recipes and the combinations, and I guess the things that humans are good at, and will do the things that robots aren't so good at, so the chopping and the peeling and the and then put that into the packaging or the capsule as you describe it, and that's then an input into the robotic kitchen, right?
Exactly. And then coming back to your question, because it's probably I still didn't make it clear what culinary engineering is. If you take a salmon, and right now it's our most sought dish, at the initial stage, the culinary engineering team, and again, these are people not from with traditional cooking background. It's more like people with master degree in food science, chemistry. They collect bunch of data about this salmon to create the algorithms, to create the formulas, to create the dependencies, how the weight of salmon depends on the heat distribution, how so interconnections between weight, granularity, viscosity of the sauce with heat distribution, and also to collect data for quality control. Because one thing is to cook autonomously, and absolutely different and much more complicated thing, how to make sure that something which was cooked autonomously will go to the customer fully cooked without any spillage and things like that. And they create, we call it robot recipes, but basically it's a digital recipe, so formulas of, and then the job of more traditional cook starts at the prep kitchen. They take salmon, they sous vide. Do you know sous vide technology, low temperature cooking?
Yeah.
So it's not fully cooked, but the proteins are gelatinized. And then they put this sous vide salmon into the capsule and ship it to the robotic kitchen. And then the order comes. The system, first of all, schedule when it should start to cook, because again, this is the precision, not from cooking point of view, but from scheduling, processing, and assembly point of view. For example, in case of delivery, we know the estimated arrival time of the rider, and the robot starts to cook exactly by to have it cooked exactly by by this time. If we can get the inputs, how far, as I said, the customer is, what's the desired state, the robots will give, or not the robots itself, kind of the brain of the system or software will give the command to the robots and to robotic oven, what amount of heat, what amount of temperature to apply.
Yeah.
And then the robot take the fully cooked dish from the oven, put onto the output shelf. And this is the only interaction between the system and humans starts. So someone, a runner, takes the dishes from the shelf, put them into bag, and hand this bag over again to the customer directly, to the rider, or to expeditor. And
how do you, obviously quality and experience is critical in food, and you've talked about the precision. How do robots manage, I guess, how do you make sure it isn't too dry or burnt, or there aren't any spillages or those types of things? How does that work? It's very easy for a human to be able to see those things, but does the robot do that?
Exactly, but again, based on precision and algorithms.
Yeah. Okay.
For example, in our case, very practical example, we measure 4 parameters. 1, the robots weigh the dish before and right after the cooking.
Yeah.
By the difference in weight, we understand what was the moisture loss.
Yeah.
And we have algorithms, we have neural networks which tell us, is it within the range or outside?
Yeah.
We do the same with the heat distribution inside our capsule, because we use a special thermal camera which creates a thermal image, because we are not able to paint it. See,
of course.
We create a thermal image, and again, this a neural network tell us if the heat distribution on this thermal image is right or not, and then we combine it with a real delivered power, not a nominal power of an oven, but real delivered power.
Yeah.
And the distribution of the temperature inside the oven's cavity.
Yeah.
And kind of combining these 2 parameters with very, very high level of likelihood, close to 100%, we can say that it was cooked properly. If not, this dish will be discarded, and the robots will start cook the same dish again.
Yeah. Okay. Okay. You talked about the interface with the human at the end of the process is where the rider collects it. Could there be an interplay with the Remy technology and autonomous delivery in the future as well?
It has always been my dream. Because, of course, we're trying to make the food service space just better. But at the same time, if you ask me about a little bit more tangible and precise dream or vision, I really believe in food delivery.
Yeah.
And I really believe in freedom of choice. So if you don't want to cook and you can't afford going to a very expensive restaurant, you should have this option. But right now, even though the food delivery changed a lot since 5 years ago, and now kind of it's a part of our life, it's still very, very far away from being that type of everyday service, because it's still a little bit unreliable, it's still expensive. And when we speak about precision, we control just the cooking part. And as I said, the cooking starts based on estimated time of arrival of a rider. But we can't control this. And sometimes riders get very late, and the food sits on the shelf becoming soggy. And if at some point of time, not if, but when, I really believe when, at some point of time, it will be connected to autonomous delivery, it will be very precise end-to-end service with ultimate experience to customers.
And is it your view that this type of technology is essential to make food delivery more sustainable, not only for the consumer but also the operator as well? Because there's still a lot of question around the actual profitability, the sustainability of the delivery business model. Do you believe that robotics are an intrinsic part of making it a sustainable business model?
Absolutely, and you are totally right. Not everyone, and I really admire this a lot, because not everyone in this space really understands. So it was a push, a drive into this food delivery space, because operators thought, okay, we can save on waiters, we can save on premium locations rent, and start our food delivery business. But in reality, everything broke up from the fact that the cost of digital marketing and customers acquisition, the cost of delivery is much more expensive. And most of the food delivery operators, they are struggling. Because to have a sustainable unit economics in food delivery only business, you have to sell more than 100 orders a day. But when you compete with thousands of the restaurants on a delivery platform, it's almost impossible. There are just few outliers in the world who can make it. All the rest, they're struggling. And I really believe that robotics is the only way to make food delivery business much more sustainable for both food operators and for the customers.
Yeah. Okay. Can I almost, and this has been great to explore actually some of the fundamental principles, but can we just go back to what is Remy Robotics? How do you describe the business? What does it do? Are you a food business or a tech business? And just give us a little bit of context about that.
No, we're definitely a technological company.
Yeah.
A restaurant or food tech company founded in Barcelona. Our main product is robotic kitchen.
Yeah.
Which, as I said, can cook multiple food types, can be flexible and adaptive from layout, throughput, and capacity point of view, and cost comparable amount of money to the traditional conventional kitchen equipment. And we've started with our own direct-to-consumer business.
Yeah. Okay.
Building our own food delivery brands and selling them directly through delivery platforms, Uber Eats, Deliveroo, Just Eat, Glover, here in Spain. Because again, as I said, we really can make this business much more sustainable. I gave you this example of 100 orders a day for a traditional delivery restaurant operator for a decent unit economics. In our case, we need just 50 orders a day, twice less.
What to break even?
Not to break even. To break even, we need to have 25-30 orders a day.
Right. Okay.
But to have a decent unit economics with 10-15% EBITDA margin, we need to have just 50 orders a day. And of course, from scalability point of view, if you want to open a kitchen in other location, it literally takes us just one day. We just bring the equipment, install it, and that's it. Robot identify the environment, and we connect to all delivery platforms, and next day we can start selling. But saying that, it doesn't mean that direct to consumer our only way to go.
Yeah.
We've put so much efforts, energy into the technology and made it so flexible that I would say the next big step is to let multiple food operators to benefit from this technology.
Yeah. Okay. Can I just talk a little bit about the brands that you've got and how they've performed? I mean, it's amazing that you have your own, not only the technology, but your own proof of concept as well in the actual brands themselves. How do they yeah, what are those brands? How do they perform versus comparable businesses that have used the delivery platforms? Yeah, tell us a little bit about them.
Okay, so coming back to flexibility, it takes us around 6 weeks to launch a fully new food concept, a food brand, consisting of let's say 15, 20 unit SKUs, unit dishes. And the main goal for us at this stage was to prove the fact that the food which is cooked by robots can be tasty and can be accepted by the customers, even not necessarily knowing that the robots are behind. So to avoid the hype involved. It doesn't mean we are hiding this, but we are not explicitly pushing for this. No. And also because it's very difficult to do through delivery platforms, because there are not that much options to communicate through external delivery app. And up to date, we've sold more than 70,000 dishes to almost 7,000 customers in Spain and France. And we have very, very high ratings. So it's 4.5, 4.6 on Deliveroo, and 96 on average percent on Glovo, because they have a little bit different way of how they review it. Also from other quantitative parameters, we have 40% loyalty rate, meaning 40% of our customers keep coming back. And these are the parameters which probably are not very familiar to a person. But such type of things like offline hours or cancellation rates, availability of your restaurant, we have almost 0%, because robots are always on.
Yes.
The system is very reliable. And if people think that because every delivery app has its own algorithms, but in reality, most of these algorithms push you up, not just based on the reviews, but based on such type of hidden parameters like cooking time, off times, cancellation rates, and everything help us to have a great ratings and be on top. But again, among all these business parameters, again, the most important for me that we have 40% loyalty rate and the highest ratings, because people really love our food and keep on coming back.
And have you got, and I appreciate that you don't necessarily communicate up front that the food is prepared in a robotic kitchen, but have you done any engagement at all with consumers around how they might feel about food that's being prepared by robots or not?
We did, and we had a special campaign here in Spain, here in Barcelona. And to be honest, I was probably the only one or the main person who was concerned the most. But the reality is completely different. So people, and I would say, look, because there are lots of discussions about the robots in general, and will they steal the jobs, and that kind of discussion. And in my case, I really believe that, and I don't really want to see robots in fine dining restaurants, because we come there to get emotions, and emotions come from human. It's a part of entertainment. But when it comes to QSR or food delivery, people don't expect any emotions. They expect reliability, hot food, which comes on time with reasonable price. And then you let people try, and then you explain that the robots are behind it, I think it creates even additional layer of credibility.
Yeah, 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 and I guess it's particularly suitable for perhaps hostile environments, whether that be where time is a barrier. Maybe it's in the middle of the night, or it's in a highly remote location, or it's an environment where people don't want to work. It's very suitable to that as well. Workplace, or I don't know, school. You can see many applications.
Exactly, and you know, we high tech is very competitive space.
Yeah,
and you always have to fight for the best talents. In our case, I hope, or I believe, I see that they have this privilege to combine, on the one hand, the cutting edge technology, which can really make an exponential impact, and on the same time, as we discussed it from the very beginning, a product which everyone has a connection to.
yeah,
and the privilege of our company that all our team is the first testers of our own product. Not that many technological company can say that. Apple people probably yes, because they use Apple iPhone on an everyday basis. But all the rest, especially with B2B product, even with B2C product, they test it because they need to test it from technological point of view, but they're not users, they're not customers.
Exactly. Whereas you can use it, taste it,
yes,
and interact with it.
It makes our job of hiring the best talents, I would say, much more easy. But it also was my dream from the very beginning. I want to aim high, and if to dedicate the next part of my life to something meaningful, create a really big social impact. But why I started to explain this, and we have very multidisciplinary business. So it's robotics, AI, software, hardware, but it also culinary engineering, cooking, logistic processes. And then you hire people from traditional food industry space. You can't even imagine how excited they are. So our two key culinary people, they're both from the United States. They spent almost all their career in New York, in very kind of, as we discussed, very harmful cooking environments.
Yes.
And right now, again, they really see how we can change this space, because instead of having cooks working in dark kitchens literally dark kitchens without windows during weekends, 12 hours a day, we move them to prep kitchens where all work very well planned, from Monday to Fridays, from 8 to 5. Completely different life.
Doing what humans are good at.
Yes. Doing what humans are good at. Yes.
Yeah. Obviously, you founded the business. I have to ask, and you touched on it a moment ago. Why? What's your kind of purpose? Obviously, you're an entrepreneur. You want to have a successful business and brand. But what's the deeper reason for you behind your motivation for Remy Robotics? Why?
Food has always been my passion, and I'm very cautious to what I personally eat, and I really believe we should be, as a society, as a humanity, much more cautious from our health point of view, from plain sustainability point of view. But at the same time, food services industry has always been very conservative from innovation and disruptions point of view. And I don't remember if we've touched this topic, but right now, especially with this labor shortage problem, it's a big difference between an automation and autonomy.
Yeah.
We can't say that the tech ignores food service industry. No, there are lots of, but mainly automation projects which are going on. ERP system, food waste control systems. But again, these are automation. But right now with labor shortage, you can't solve this problem just with automation. You can build even robotic solution to automate a single process, like, I don't know, deep frying something.
Yeah.
Does it solve a problem? Yes. What kind of problem? A problem of this particular restaurant. But will it solve, or does it solve a problem in general? Not. And it's impossible to solve without an autonomy.
Yeah,
in the same way, like with autonomous driving. It's been my kind of thinking and consideration at arrivals time. Yes, electric vehicles makes lots of things better, cleaner cities, but autonomous driving, it's a real game changer.
Yeah.
And the same is here. Automation of food service industry, because this industry really requires lots of improvement. We know how unsustainable in the way it is. But only autonomy can be a real game changer. And then when at some point of time, I realized that the state of technology is ready with some limitations, because again, as I said, like Star Wars android type of the robots which can cook and manipulate in the way humans do it, like I don't know how many years from now.
Yeah.
But in the way, if you approach it in a smart way, can already start approaching this big game changer idea. This was my moment.
Reimagining the entire process, because I guess we have cooked in the same way for hundreds of years, really, and this is a reimagination of a more autonomous model.
Yep.
Yeah. My last question is, tell us what's next for Remy Robotics. What's next in the plan?
We proved everything what we needed to prove in startup environment. It's called product market fit here in Europe. Mm-hmm. So the system is very reliable. It's close to 100%. People love our food. We have very stable and decent ratings. So the food is really consistent. We proved everything from unit economics point of view. And now the next step to the biggest food service market in the world. We really want to expand. At the same time, as I said, we started with our own direct-to-consumer business. And I really believe that we can create a food delivery operator of the future. But at the same time, our own food delivery business is an essential enabler for our technology. Yeah. Because there is no way you can come to any existing food operator and start automating their processes.
No.
It won't work in this way, because again, as we touch upon those processes, tools, appliances, equipment which were designed and built by humans for humans,
they don't work. No.
It didn't work. But now then the technology is ready, and every week we have lots of visitors keep coming, trying the food and understand how the processes work. The next step will be also to become a technological enabler for multiple food service operators, and not necessarily food service operators, also catering company, healthcare, airport lounges. There are lots of demand for such type of application. It will be very important year for us.
Yeah, well, we wish you all of the luck with the rolling out and growing the concept. Really exciting. It's been absolutely fascinating to talk to you. So yeah, that concludes this episode of the Food People in Conversation with Yegor. On behalf of us all at the Food People and the In Conversation with audience, thank you so much for joining me today, for sharing the Remy Robotics story and really opening our eyes as to the possibilities with autonomous and adaptive and flexible robotics and the role that can play in the food service environment. So thank you so much for joining us.
Thank you very much, Charles. It was an honor for me, and your question and your knowledge of this space, I appreciate it a lot. Thank you very much.
Thank you very much. So do join our TFP community for the details of our latest In Conversation with episodes, as well as the latest free-to-access food and drink trends foresight. Visit thefoodpeople.co.uk. Complete your details at the footer of the page. On behalf of Yegor and myself, thanks for listening to the Food People in Conversation with. Join with us in the trends of today and the foresight of tomorrow to shift the future of food and drink, and leave you with one question as always, and that is, how are you shifting the future of food and drink? Thanks for listening.